So there is a pattern. So we said on day one, you get a check for $1. You have a total of $1. Day two, check for $2. You got a grand total of $3. Day three, you got a check for $4. Grand total of? You had 3, you had 4, you got $7. You're adding these numbers. I got a check for $1. I had $1. I add 2, I get 3. I add 4, I get 7. Right? So on day 4, I'm gonna get a check for $8. I got a grand total of $15. Anybody see a pattern yet? All right, let's try this again. Day 5, check for 16. Grand total of 31. What? You're close. You're close. Let's try this again. Day 6. What's your check for? 32. Okay. Put some lines in here to try to help you. So what's the total? Add those together. 63. Does anybody see the total? Anybody see the pattern? What? The next check's going to be 64, which is, right? So if I can figure out this number, I know that number, right? So, how am I figuring out these numbers? What type of growth is this? What type of equation is this? What type of pattern is just this column? I think somebody said it. It's exponential. This is an example of exponential growth. Now, fast forward to day 30. Now, 7 days in, do I have a whole lot of money? I'm a week into this, right? And I've only got $127, grand total. Okay? I mean, Patrick Mahomes on $127, yeah, he's going to be upset. That's a whole week's worth of work. Right? Anybody figure out, how would I quickly figure out day 30? Why 2 to the 29th? Right. So if you think about the pattern and you write it as exponential, 2 is the same thing as 2 to the first power. 4 is 2 squared. This is 2 to the third. So day 1 is actually 2 to the 0 power. So it's kind of behind by a day, right? Because we started at 1. So fast forward to day 30. How much is his check going to be worth? How could I calculate this? 2 to the 29th power. So just his day 30 check would be 2 to the 29th power. The one single check. This is not adding them together. This is just the last check. He would get $536 million, $870,000 kind of thing. So just the last check would be way better than the other option, wouldn't it? How could I quickly calculate all of them added together? If I know this number, how can I find this number? Then what? This 127 isn't one less than this. It's one less than the next number, right? So to figure out the grand total over here, I actually want to figure out what he would have gotten on the 31st check, which would be what? 2 to the 30th. And just do what? Minus 1, right? Somebody did 2 to the 30th. Or just times that by 2. So it's 2 to the 30th. Somebody had this on their calculator. It's 1,073,000,000, right? Basically, if he would have chose option 1, he threw away basically $1 billion. Okay? I'm just making this up. It's a fun math problem. It didn't actually give the choice. He went with option 1. He wasn't very smart. Yeah, he threw away $1 billion. Yeah, well, we all thought he was a smart dude. He threw away $1 billion. Now, is this the actual total? Instead of a 4, it should be a 3. So, this is an example of exponential growth. That's what we're talking about here. The question is, how do exponential growth functions grow? Did this start out very quick? No, it was growing very, very slowly. The difference between the first couple checks, I mean, he only made $1, and then he got $2, and then he got $4. The rate of growth at the beginning was very, very slowly, right? Now, what is the difference? Like if I figure out for a check on day 5 compared to on day 6 compared to day 5, right? Just find the growth of how much more it went up, right? It only went up by $16. But if I do the same thing towards the end and I say, what's the difference between the 30th check and the check before it? What is the difference between those two numbers? Is that going to be a small number or a big number? It's going to be huge. He got an extra $268 million towards the end on each check, kind of thing. So what happens with exponential growth, if you graph this, okay, you have a normal XY axis. What happens is it starts growing very slowly, right? But the faster it grows, the bigger it gets, the faster it grows, right? It's basically equivalent of getting a car. You think about an unlimited car, unlimited acceleration, unlimited car. You get in the car, you slowly touch the gas pedal, so it's not moving very fast. But the faster you go, the harder you press the gas pedal. So now you're accelerating faster. And then now that you're going faster, you press the gas pedal a little bit harder, and now you're accelerating even faster. This is actually how stars will explode, because stars start growing. Now, when they're small, they're growing, but they're not growing very quickly, right? So the rate of growth is very, very slow. But as they start to expand and they get bigger, not only are they bigger, they're expanding faster. So now think about millions of years of this going on. They've gotten huge, and not only are they huge, they're growing at an insanely fast rate, and eventually it becomes unsustainable and the star just explodes, right? Now this happens over billions of years, but because things, when does all the change happen? Does it happen at the beginning or does it happen at the end? It's all at the end, because this is exponential growth. Exponential growth is actually the fastest way any function can grow. There is no function in the world that will be able to grow faster than an exponential function. Now, exponential functions work very interesting, because on the positive side, it goes like this. Now, almost all exponential functions, all basic exponential functions, will go through one key point. What are the coordinates of this point right here? It's not 0, 0. Y. Why will all exponential functions go through that point? This is basically the graph of y equals 2 to the x. Why will they all go through that point? Any number to the 0 power is 1. So we're always going to hit that point. Now, Who's got a pencil I can borrow? Can I borrow that pencil real quick? Thank you. Now, on the left side, something interesting happens, right? So on the right side, we're multiplying by 2, multiplying by 2, multiplying by 2, right? On the left side, something interesting happens. Now, I'm going to give you your pencil back, okay? You gave me your pencil here. Going this way, how are you going to the left? You are dividing by 2, okay? Now, I gave part of his pencil back. So he has now half his pencil. Okay, and then what's the next step? Okay, I'm going to give him half his pencil back. Okay, and this pattern continues. Okay, once it gets too small, yeah, you gotta have some pretty strong fingers to keep going. Now, what's going to happen to this curve? Will he, if I were to be able to do this infinitely many times, now, eventually, it's going to get so small you can't even see it. Will he ever actually get his full pencil back? Why? I'm always going to have a little part, right? I mean, eventually it's going to be so small I'm going to be splitting atoms, which is never a good idea in a classroom. You should never split an atom in a classroom. It's really dangerous, right? It's called an atom bomb. It's basically how atom bombs work. Bad things. So, and I'll give you a new pencil. Don't worry about it. So, what happens on the left side is this curve is going to keep getting closer and closer and closer to 0. Will it ever actually reach 0? No, but it's going to get so infinitely close that it looks like it's at 0, but it actually never reaches it. This is called an asymptote. This curve is going to get closer and closer and closer to this line, but it'll never actually reach that. Make sense? This is an example of exponential growth. Exponential decay graphs basically go exactly the opposite. Okay? If I take his pencil and I keep breaking it in half, breaking it in half, breaking it in half, it's going to get closer and closer and closer to 0. On the left side, it goes to infinity on this side. This would be an example of something like 1/2 to the x power. Now, how can we tell whether it's exponential growth or exponential decay? What is that main deciding factor? Comes down to that number. What is the difference between a number like 1/2 and a number like 2? What's that deciding factor of whether or not it's going to be a growth or a decay graph?
1/2 is 2 to the negative 1, so it's going to make the exponent negative.
Well, it's not really about the negative exponent, but it is a good thing to keep in mind about negative exponents, because that's going to come into play later. But what is crucial about that number right there? So what kind of numbers can you multiply by that the result will get smaller? Less than 1. If this number is bigger than 1, the number that's raised to the exponent, if that number is bigger than 1, you are going to see an exponential growth graph. Almost all the graphs look basically the same. The difference between y equals 2 to the x and y equals 5 to the x, the difference is the graph would look like this. Almost identical. It would just go up a little bit faster. The graphs don't really look much different. Okay? But as soon as you get to a number that's less than 1, the graph flips and goes the other way around. Simple? All right, everybody take a look at page 341. Oh, you're going to get a really tough homework assignment today. The first few problems, all you got to do is plug the number in and give me the answer. It's just easy. Number 10. You have to graph y equals 7 to the x power. 341. Is that a growth or a decay graph? That's growth. I want you to draw a basic sketch that looks like this. Show that it goes through the point 0, 1. Done. When you do number 12, it says 6 to the x. Is that growth or decay? That's growth. Done. 14, is that going to be growth or decay? But it's a 10. Why is it decay? Because that negative exponent. What do we do with negative exponents? We flip. That is the equivalent of 1/10 to the x power. So, done. I don't need you to plot points. I don't need you to right now draw big fancy graphs, make them look good. This is just simply about, is this growth? Is it decay? Do you know what a growth graph looks like? Do you know what a decay graph looks like? That's it. Okay? Easy? All I want you doing, 2 to 30 even. There's a couple tricky ones. Try plotting a couple points. See if you can figure out what's going on there. There's a couple at the end with the number E. And yes, I said that sentence correctly. Anybody know what the number E is? 2.71 approximately. It's an irrational number, just like pi. Okay, we'll talk about that in depth in the near future. So a graph like y equals e to the x, would that be a growth or a decay graph? That's going to be growth because it's about 2.71, which is bigger than 1. It'll look a whole lot like 2 to the x. Easy?